Welcome to Star Chat, the podcast, where we explore the wonders of the universe and all its secrets. I'm your host, Carl, and I'm thrilled to have you join me on this journey through the cosmos. Today, we're going to talk about some exciting new discoveries that are helping us better understand our place in the universe. First up, let's dive into a fascinating story about the first stars that formed in our universe. For a long time, scientists thought that these early stars were all massive, but new research suggests that might not be the case. In fact, it's possible that some of these stars were much smaller and more similar to the stars we see today. This new understanding is thanks to a pair of studies that looked at the formation of the first stars and how they impacted the universe as a whole. One study focused on the role of helium in the formation of these early stars, while another looked at the ways in which the first stars influenced the growth of galaxies. Together, these findings are helping us paint a more complete picture of what the universe was like in its earliest days. And who knows, maybe one day we'll discover that some of these small, early stars are still out there, shining away in the vast expanse of space. But that's not all. We're also going to talk about a new method that NASA scientists are using to map star spots on distant stars. This technique uses data from the TESS and Kepler spacecraft to create detailed maps of these stars' surfaces, which can help us learn more about their activity and the planets that orbit them. It's a pretty cool technology, and it's already giving us some amazing insights into the properties of stars and their planetary systems. For example, scientists use this method to study a planet called TOI 3884b, which is located about 141 light-years away in the constellation Virgo. By analyzing the star's light curve, they were able to determine that it has concentrations of spots at its north pole, which is pretty interesting. And with NASA's upcoming Pandora mission, we'll be able to use this technology to study even more stars and planets in unprecedented detail. So, whether you're interested in the first stars that formed in our universe or the latest advancements in exoplanet hunting, we've got you covered on Star Chat. We'll be right back with more fascinating space news on Star Chat. Welcome back to Star Chat. As we continue to explore the wonders of the universe, we're also reminded of the challenges that come with advancing technology and human activity. Today, we're going to talk about a growing concern in the field of astronomy: satellite light pollution. You might have heard about the thousands of satellites orbiting our planet, providing internet connectivity and other services. But what you might not know is that these satellites are also reflecting sunlight, leaving bright marks in telescope images and potentially affecting scientific observations. This is where experts like Dr. Meredith Rawls come in. As a researcher at the University of Washington and a leading expert in astronomical image processing, she's been working to mitigate the damage caused by satellite light pollution. Dr. Rawls joined the Vera C. Tarbra Rubin Observatory project back in 2016 with no idea that her career would take a turn towards tackling this unexpected challenge. But as SpaceX began deploying its Starlink constellation, the astronomical community started to sound alarm bells. The satellites were orbiting too low and reflecting too much sunlight, leaving bright marks in telescope images. Dr. Rawls and her team made a scientific assessment of the satellite streak's effect on astronomical observations using images from the Victor M. Blanco telescope. Their findings showed that although the streaks weren't overwhelmingly bright, they still risked affecting scientific observations. This led to the development of an entirely new subdiscipline of astronomical image processing, focusing on techniques to remove satellite light pollution from data and designing observation protocols to prevent too bright satellites from spoiling the views. Rawls has become one of the leading experts in this fast-evolving field, which is only set to grow in importance in the coming years. The number of satellites orbiting our planet has risen dramatically, from just over 1,000 15 years ago to more than 12,000 active satellites today. And with ventures like AST Space Mobile Building, giant orbiting antenna arrays to beam 5G connectivity directly to users' phones, the light pollution problem is only going to worsen. But Dr. Rawls remains optimistic that she and her colleagues can stay on top of the problem. As we continue to push the boundaries of space exploration and technological advancement, it's essential to consider the potential impact on our ability to study the universe. The work of experts like Dr. Ta Rawls is crucial in ensuring that we can continue to explore the cosmos without being hindered by human activity. Stay tuned for our final story of the day, right here on Star Chat. Welcome back to Star Chat. We've had an amazing conversation so far, exploring the wonders of the universe and all its secrets. As we wrap up today's show, I want to leave you with a fascinating story that highlights the importance of understanding our relationship with the sun. You see, our star is not just a big ball of hot, glowing gas. It's a dynamic and powerful force that affects our daily lives in ways we often don't even realize. From the beautiful aurorae that dance across the polar skies to the potentially devastating solar eruptions that can cripple our technological infrastructure, the sun is an awe-inspiring entity that demands our respect. I recently had the chance to speak with Dr. Tamitha Skov, a renowned space weather expert, about the impact of solar activity on our planet and beyond. She shared some fascinating insights into the ways in which solar storms can affect everything from power grids to GPS systems and even pose significant risks to astronauts exploring the Moon and Mars. One of the most striking aspects of our conversation was the realization that we've been lucky so far in avoiding a major solar eruption like the Carrington event of 1859. If such an event were to occur today, it could have catastrophic consequences for our modern technological society. Dr. Skov emphasized the need for continued research and development of mitigation strategies to protect our infrastructure and ensure the safety of space travelers. As we look to the future of space exploration, it's clear that understanding and preparing for space weather events will be crucial to our success. Whether it's developing new technologies to shield against radiation or creating more resilient systems for navigating the challenges of space travel, the study of space weather is an essential component of our ongoing quest to explore the cosmos. So as we conclude today's Star Chat, I want to leave you with a sense of wonder and appreciation for the complex and dynamic relationship between our planet and the sun. Remember that the next time you gaze up at the stars, you're not just seeing a pretty light show, you're witnessing the intricate dance of celestial bodies that shape our very existence. That's all for today's Star Chat. Remember to like, share, and subscribe, and until next time, remember to keep looking up at the stars.